electronic technology used to implement it. So they can be classified into number 1, TTL based microprocessors, number 2, CMOS based microprocessors, number 3, ECL based microprocessors. So the full form of TTL is transistor logic, and the full form of CMOS is complementary metal oxide semiconductor based microprocessors, and ECL means emitter coupled logic. So TTL based microprocessors are commonly used, whereas CMOS based microprocessors consume less power, so that they are used for battery powered devices, whereas ECL based microprocessors are faster and they are more expensive and they consume more power. So depending upon application, one has to select the microprocessor. So further, microprocessors are further classified depending upon the data format, the width of data format. So they can be classified as number 1, 4-bit microprocessors, number 2, 8-bit microprocessors, number 3, 16-bit microprocessors, number 4, 32-bit microprocessors, and finally 64-bit microprocessors. So the 4-bit microprocessors are the cheaper and the slowest microprocessors, and the 64-bit microprocessors are the fastest and expensive microprocessors. So depending upon the application, select the microprocessors. And finally, microprocessors are further classified depending upon the instruction set. So they are classified into CISC processors as well as RISC processors. So the full form of CISC is complex instruction set processors, and RISC means reduced instruction set processors. So the complex instruction set processors are having from 70 to couple of hundreds of instructions, and they are easy to program, but they are slow and expensive. So if you see for RISC, they are having less number of instructions compared to CISC processors, and they are faster and cheap. So depending upon applications, one has to select microprocessors. So many varieties of microprocessors are available. So depending upon application, one has to select the appropriate microprocessor. So let me introduce you to the microprocessor 8085. So 8085 is an 8-bit microprocessor introduced by Intel in 1977. So it was implemented using NMOS as well as CMOS technology. And 8085 plays an important role in the study of microprocessor. The reason is that it is simple to understand, and for the beginners it is better to understand 8085 first before going to the programming of the microprocessor, before learning the programming of microprocessors. 8085 is simple to understand and the programming is simple. So before learning microprocessors, it's better for beginners to learn about 8085. So first let's see about architecture of 8085. So I got the architecture of 8085 drawn on this board here. So you can, so this is the architecture of 8085. So 8085 consists of ALU, arithmetic logic unit, an accumulator, temporary register, flip-flops, flag flip-flops, interrupt controller, instruction register, an instruction decoder, timing and control register, address buffer, data and address buffer. These are general purpose registers B, C, D, E, H and L. Every one is an 8-bit register here. This B, C, D, E, H and L. A stack pointer, program counter, increment and decrement range. And you can observe that here the address bus is of 16-bit and the data bus is of 8-bit only. And these are the control signals from here to here. And these two are DMA signals and these are reset signals. So which are very important. These signals are very important in the operation of microprocessor. And these are the interrupts. So interrupts are also very important in communication with microprocessor, the external device communication. This is serial I/O. This is also used for long distance communications. So let me explain you each and every block in detail. So the first block I want to explain is timing and control block. Timing and control block is a very crucial block in microprocessor. So it is responsible to execute the already decoded instructions. So it generates signals which helps in execution of instructions already which are decoded. Next, this timing and control block is responsible to send data to the block wherever it is necessary. And in fact, it acts like a coordination between different blocks in the microprocessor. Next, ALU. The full form of ALU is arithmetic and logic unit. The arithmetic and logic unit of in 8085 microprocessor is a thing which perform all arithmetic and logical operations. So arithmetic operations means like addition, subtraction, increment and decrement, and logical operation means compare, logical and logical OR. And this arithmetic and logic unit uses accumulator to store its result. Next, register. So as you see in the architecture which I have shown before, there are many types of registers in 8085. So those are number 1,